Hello students, good morning students. Crystal field theory applications look at here. PYQ questions, I am explaining here one of the PYQ question, crystal field theory based. Which one of the following complexes will have delta naught value equal to 0 and mu equal to 5.96 in Bohr magneton? Bohr magneton value is given and also they given the information delta naught equal to 0. So which of the following complex? This is a PYQ question. First of all, identify the ligands. Which ligand is the weak ligand? Which ligand is the strongest ligand? Observed here in these complexes. This one is the strong ligand. Cobalt plus 3 case. Cobalt oxidation state here plus 3 case. And chromium plus 3 case. Cobalt plus 3, chromium plus 3 case. Amine is act as a strong ligand. But remaining all cases, it is act as a weak ligand, NH3. Next, halides are weak ligands. In the spectrochemical series, halogens are existing last. So, they are the weak ligands. SCN, thiocyanide, also act as a weak ligand. This is a weak ligand. What is the iron oxidation state here? Observed here. Cyanide is the negative ligand, -6. Here the -6. Here the +2. Iron is +2 oxidation state. 3d6, 4s0. Here, how many unpaired electrons are present? Unpaired electrons in this metal ion 1, 2, 3, 4, 5, 6. So this is the valency bond theory based expression. This ligand is the strong ligand. In the strong ligand, as per the crystal field theory, the 5 d orbitals are split into 2 energy levels, that is T2Z and EZ. Lower energy state T2EZ is present, in the higher energy state EZ is present. T2Z, EZ. The ligand is a strong ligand. Electrons are existing here in the ground state only, not pairing takes place. 1, 2, 3, 4, 5, 6. The 6 electrons arranged here. 1, 2, 3. This is a strong ligand. Pairing takes place. 4, 5, 6. T2Z6, EZ0. In the EZ, no electrons. It is a diamagnetic in nature. So magnetic moment value 0. Magnetic moment value. But here the magnetic moment value, how much is given? 5.96. 5.96 magnetic moment value 5.96 indicates the complex, the metal ion having the 5 unpaired electrons. Simple. It is a strong ligand. Cobalt plus 3. Cobalt plus 3 means 3d6, 4s0. 3d6, 4s0. Here NH3 is a strong ligand. Electrons are pairing takes place. Magnetic moment value, here the 0. Unpaired electrons are not present as per the crystal field theory. Next F6. Here the -6. Here +2. Iron is +2. So 3d6, 4s0. 3d6, 4s0. Here fluoride is a weak ligand. So electrons are not pairing takes place. So the 6 electrons, 3d6, the 6 electrons, 1, 2, 3, then 4th electron enters into the EZ. 4, 5, 6. So T2Z4, EZ2. T2Z4, EZ2. How many unpaired electrons are present here? 1, 2, 3, 4 unpaired electrons are present. 4 unpaired electrons are present. Bohr magneton value almost we are getting 4.90. 4.90. The last complex observed here, SCN minus, here the -6, here the manganese is +2. Manganese valency is 3d5, 4s2. So manganese +2 means 3d5, 4s0. 3d5, 4s0. Here how many unpaired electrons? 5 unpaired electrons are present. Bohr magneton value we are getting 5.96 something. 5.96. So the value is here this complex. Find out the crystal field delta naught value. CFSE value we are finding for this complex. CFSE value. So crystal field stabilization energy, it is an octahedral complex. For octahedral complexes, what is the formula? -0.4 into In the T2Z, how many electrons are present? In the T2Z, 3 electrons are present. Here the 3D5, here the 3D5, 1, 2, 3, 4, 5. This is EZ2, this is T2Z3. So 3 electrons are present plus 0.6 into 2 electrons. So what is the value? Minus 1.2 plus 1.2. So crystal field stabilization energy value is 0. So answer is this one. So weak field ligand, strong field ligand observed carefully. Then only we are getting the answer. One more question, look at students. Another question. Next question observed here students. Different complexes, 4 complexes are given. They are asking in terms of wavelength arrange these complexes. So one hint I am giving you. What is that hint? For example here, if the ligand is the weak ligand, crystal field splitting energy gap is less. If the ligand is a strong ligand, crystal field splitting energy gap is more. This is the hint for this question. Ligand is the weak ligand case, here the ligand is a strong ligand case. So energy gap is less means wavelength is more in the case of weak ligands. Strong ligand, energy gap is more means wavelength of the light absorbed is less. That is the hint. So observe here in the given complexes, NH3 acts as a strong ligand. Cn also strong ligand. NH3 and Cn, which is the strongest ligand as per the spectrochemical series? Cn is the strong ligand compared to NH3. So strong ligand gives energy gap is more, wavelength is less. Between these two complexes, which is the less wavelength? This one is the less wavelength. Next here, CONH3 5 times H2O is present. CONH3 5 times Cl is present. NH3 is the common. NH3 is the common. Another ligand, what is present here? Cl. Another ligand, what is present here? H2O. H2O and Cl, which is the strongest ligand? H2O is the strongest ligand compared to halogens. So here the weak ligand is present among all the complexes. So ligand is the weak ligand means absorbed wavelength is more. So which is more wavelength value? D. After D, A. After A, B. Which is the least? C is the least because of the strength of the ligand is more. So strength of the ligand is more, wavelength is less. Strength of the ligand is less, wavelength value is more. This is a hint observation. Easy question. This is also PYQ question. Next, one more question, students. Observe the next question, students here. The correct increasing order of stability of complexes based on delta naught values. 4 complexes are given. Increasing order of delta naught value, crystal field stabilization values they are asking. Here observe the first complex oxidation state of the manganese. Here the -6, ligand is -6, manganese is +3. Manganese +3, 3D4, 4 electrons are available. Next here -1, here the -6, cobalt, what is the oxidation state here? +2 oxidation state. Cobalt is +2 oxidation state. Next here the -6, iron, here the +2, iron +2 oxidation state. Next here the -6, here for getting -3, iron is the +3 oxidation state, +3 oxidation state. All are first of all strong ligands. Strong ligands means octahedral complexes. In the octahedral complexes, which orbital is present in the lower energy? T2Z. T2Z set of orbital present in the lower energy. In the higher energy, EZ orbital is present. So the electrons are not possible to exist in EZ orbital. All the electrons are present in the T2Z orbital. Here cobalt +2 means 3D7. Iron +2 means 3D6. Iron +3 means 3D5. So 3D4, the 4 electrons are present in the T2Z only. T2Z 4, EZ 0. Next year, T2G6, EZ 1. Next here T2Z 6 EZ 0. Because of strong ligand, electrons are pairing in the T2Z only. 3D5 T2Z 5 EZ 0. The electrons are not present in the EZ. Now observe the each complex crystal field stabilization energy values. First complex, observe that. First complex crystal field stabilization energy value minus 0.4 into 4 electrons are present plus 0.6 into 0. So what is that value? Minus 1.6. Next second complex crystal field stabilization energy value for second complex T2G6 EZ1. So minus 0.4 into 6 plus 0.6 into 1. So 2.4 minus 2.4 plus 0.6. So minus 1.8. Minus 1.8. Third one, observe that third complex. So crystal field stabilization energy value for third complex. Here T2G minus 0.4 into 6 plus 0.6 into 0. So minus 2.4 delta naught. Minus 2.4 delta naught. Fourth complex crystal field stabilization energy value. So in the T2G 5, in the EZ 0. So minus 0.45 plus 0.6 into 0. So minus 2.0. 2.0. So observe the magnitude value, students, here. Magnitude point of view, which one is more value? Third one. Third one. After that, fourth one. Then second one. Then first one. Magnitude point of view, third complex. Then fourth complex. Then second complex. First complex. This is the order. Magnitude crystal field stabilization energy value. This is also PYQ students. Next go to the one more question, students. PYQ question observed here, students. The d electronic configuration of octahedral cobalt 2 complex Bohr magneton value is given 3.95. Which electronic configuration is the correct electronic configuration? How to identify the electronic configuration? Here, which complex they mentioned? Octahedral complex they mentioned simply. Octahedral complexes in the lower energy state, which orbital is present? T2G is present. In the higher energy, EZ is present. Lower energy T2Z, higher energy EZ. So this option is the wrong option. So EZ, T2Z they mentioned. Remaining three options check here. Cobalt plus 2. Oxidation state of the cobalt, what they mentioned here? Plus 2. And Bohr magneton value is given 3.95. 3.95 is given means unpaired electrons 3 are present in that electronic representation, electronic configuration. So cobalt oxidation state is plus 2, cobalt general valency 3d7 4s2. After losing the 2 electrons, 3d7 4s0. Here in the D, 7 electrons are present. The 7 electrons, how they are existing? Here T2G6 EZ1 means how many unpaired electrons? 1 now. This is not correct because of T2Z only 3 electrons they mentioned. Here T2Z5 EZ2 they mentioned. T2Z5 EZ2. T2Z5 EZ2. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Here the T2Z 5 electrons in the EZ 2 electrons. How many unpaired electrons here? Unpaired electrons 3. So Bohr magneton value 3.95. This is the correct electronic configuration. Okay, now students, go to the next question. Observe here, students, number of complexes, even number of electrons in the T2Z orbital. Even number of electrons in T2Z orbitals. Observe the complexes, central metal atom here, iron, cobalt, copper, chromium. All the ligands is the same. Ligands are same. H2O, aqua. H2O basically act as a weak ligand. Weak ligand. So what is the iron oxidation state here? Plus 2. That means 3d6, 4s0. Cobalt plus 2 means 3d7 4s0. Cobalt plus 3 means 3d6 4s0. Copper valency configuration 3d10 4s1. One electron is present in the s orbital. Here plus 2, copper plus 2 means 3d9 4s0. Copper plus 2. Chromium electronic configuration 3d5 4s1. 3d5 4s1. One electron from the s orbital, another electron from the d orbital. Chromium oxidation study at the plus 2. So 3d4 4s0. 3d4 4s0. All are octahedral complexes splitting. You know that T2Z is the lower energy, EZ is the higher energy, H2O is the basically weak ligand. Remember this. H2O is a weak ligand in these complexes. So observe the first complex based. This is T2Z and EZ. 6 electrons are present. 1, 2, 3, 4, 5, 6. Here, how many electrons are present here? 4 electrons. That is even number. The question is what? Number of complexes with even number of electrons in the T2Z. First complex is even number of electrons in the T2Z. Next complex here, the D7 is there. D7 means in the T2Z and EZ. 1, 2, 3, 4, 5, 6, 7. How many electrons? 5 electrons are present. So second complex not possible. Here the 6. 3d6. So 1, 2, 3, 4, 5, 6. This complex also possible. This complex also possible. Next here copper plus 2. How many electrons? 9 electrons. So 9 electrons means in the D, in the T2Z and EZ. 1, 2, 3, 4, 5, 6, 7, 8, 9. So even number of electrons are present. 3. Next here chromium plus 2. Chromium plus 2 D4. D4 means in the T2Z how many electrons? 1, 2, 3. Here the 4 odd number. So how many complexes? 3 complexes in the T2Z having even number of electrons. 3 complexes in the T2Z having even number of electrons. This is the question. Okay, students, go to the next question.